Okay, guys, this is our final lecture on copper or metal conductors. After this, we will probably be in the lab next week, and then we have a test scheduled for next Thursday. Then we're going to be off for our fall break. Then when we come back, we'll be in fiber optics. So, cable wiring and installation, or actually cable splicing and installation, metal conductor installation. So what we're going to do in here is key points we're going to look at is how can a wire and cable be installed, what are the advantages and disadvantages of various installation methods, how are wire and cable spliced and terminated, what are the differences between the medium and the low voltage splicing and termination. Unfortunately, we can't do the medium voltage or the high voltage. So what we'll do here is we'll look at a video. This is some terms we'll be looking at. Bending radius, this is a quarter circle that a cable follows when it is routed around a corner. We have to honor bending radius because one thing, it puts a lot of strain on the cable, and also we could add inductance to it if we bend it too tight. So this is something we have to honor when we pull these cables. Conduit, we're going to look at conduit in this. These are raceways. Raceways are basically metal or plastic troughs or tubes that we run cables through. A tube or trough used to route conductors and cables used for protection. Fish tape, this is a flexible metal device that we use to pull or thread cables through conduit. The pulling is the act of threading cables in conduit. Penciling, this is taping insulation to a shape of a sharpened end of the pencil. We'll look at that. The splice, the physical connection of two or more conductors to provide electrical continuity. Electrical continuity, of course, is 0 ohms, or practically 0 ohms. We know now that we can't get 0 ohms. But little or no ohms between 2 points, we refer to that as continuity. And of course, termination is the act of bringing the conductor to its final connection. Conduit. When we use the term conduit, this usually refers to round pipes that we run our conductors through. These could be steel pipes. They could be aluminum pipes, or they could be material pipes, or they could be plastic pipes. There's a lot of different types of conduit we can buy. But they do fall into these categories: rigid steel conduit, enameled, electrical metallic tubing, flexible steel conduit, underfloor steel raceways. Raceways, by the way, are usually, I will look at that. Cellular steel raceways, steel wireways, steel busways, liquid tight flex conduit, auxiliary steel gutters. We'll look at some of these. This tells us where these different conduits are actually allowed to be installed. So this is a real neat chart that you might look at. If you had to get conduits, what you would do is you would look at all the different ways we can install that, and then we would come in here and we would see what's permitted and what's not permitted. Of course, exception, you would need to look this up in the National Electrical Code. So all these are in National Electrical Code, by the way, on these conduits, and actually see what that exception is. Conduit, below ground conduit, these are most commonly used. We usually use fiber or a polyvinyl chloride or PVC. Above ground, we use EMT, which is electrical metal tubing. Just about everybody in the electrical code refers to this as thin wall. Then we have intermediate metal tubing, IMT. Then we have rigid metal tubing. These could either be galvanized steel or enameled steel. This would be a coating on the outside of it, enamel coating or a painted coating on the outside to prevent it from corroding outside. And then aluminum could also be PVC. We'll look at liquid tight, flexible, non-magnetic conduit, and then flexible metal conduit. So this is below ground conduit or underground conduit. And of course, this can be, could possibly be a fiber conduit. What do they call that? Fiber. We usually use fiber if we're going to encase it in concrete. But concrete doesn't get along with a lot of metals because it's got a lot of elasticity to it when it's curing. So normally in concrete, we try not to use metal conduit. We do use PVC. PVC has no problem running through conduit. So a lot of newer houses, a lot of new houses, we call them slab houses now. Used to, when I was a kid, if you had a house, you had a underground or what we call a crawlway, which was really neat. Most houses now, they just come out and pour a concrete slab. But what they have to do is they have to run all your piping and your electrical and everything. If you live in certain neighborhoods, we run those through the slab. Of course, most of the time, what they're going to use is PVC or some type of plastic. This is above ground, so we have the conduit. We have some that are threaded, or we have some that where the couplings have to be threaded. So a lot of these pipes, they'll come. We usually use this when we get into the IMT or the rigid conduit. These usually use threads. Your thin wall or your EMT does not use threads because its wall is extremely thin, and this is what makes it pretty cheap. You can get, I think, a 10-foot length of EMT or thin wall. Used to Lowe's would sell it for a couple of bucks. It might be a little more than that because it's been a real long time since I've had to buy this. I used to teach the commercial wiring class, and of course we had to stock up on thin wall to teach that course. And I could tell you what the cost would be, then, but Mr. Sanders does all the electrical classes now, and he could probably give you a good idea. Or you could go to Lowe's and just look up their thin wall and see how much it costs. But what we do here, we use coupling, and we'll look at this, the type of coupling we have to use on thin wall. And hopefully we'll get time, and I got to go by the electrical class anyway and look at it. But hopefully I'll get time to go over there and see if there's any conduit still ran the last time they did commercial wiring. And what we might do is we might go over there to A building. I know there's a lot of nice conduit that's exposed out on the wheelchair lifts, but we could go into the commercial wiring class and maybe they still have a setup in there that we can look and get an example. We'll see. I'll let y'all know. These are EMT coupling. So what we do on EMT is we have coupling that we put on the thing. And then we come up here and we have what we call a one-hole strap, a thin wall conduit clamp, a drive-in strap, which we would drive into like a joist, a floor joist, or into a stud inside a wall. So this would be that. Then we have compression types. So compression types, what they've got is they've got a little sleeve, and that's what we'll also do. That'll be a good class. We'll go over there, and we'll go into room 208, which is our wiring lab, and we'll look at all these different types of joints that we have, or couplers that we have, how we can couple them together, how we can put the screw set, which are very, very popular. These are cheap. How we bond them and move them together, and how we attach them, and look at this, how we splice the conduit together with either the couplers, the compression couplers, or the set screw couplers, and we'll look at all these. But this is what we use on EMT. So EMT, what we're going to do is we're going to come over here and we're going to put some type of coupler over here, an end coupler or a splice coupler or a connector. And then we're either going to use compression type, which means it's got an outside shell that you start twisting, and it actually clamps down on it automatically. Those are usually more expensive. What you're going to see a lot is the set screw type couplers that we couple these together and join them together, and we'll look at that. By the way, and we'll try to look a little bit about into bending, how we bend the conduit. So normally you only use these connectors when you bring it into a box or when you put two sticks of conduit together. Anytime you're trying to bend this, anytime you're trying to run it around a corner or upstairs or something like that, then what we do is we use what we call a bender. And we'll look at that too when we go over there, and we might, if we got some over there, we'll look at a little bit of bending. So this is a liquid tight. What we have is we have a flexible metal conductor, and then we have a plastic liquid coating on that. And what we do is if we're running, if we're using this, since the outside is plastic, and this is a compression, so what happens with the compression is we get our ground either through this or we get it through a grounding strap that we run down the side of the conduit. And we'll look at that too and figure that out. Wireways and wire ducts, also called cable tray types or cable trays. We have the ladder type, the trough type, the channel type, and then the solid bottom type. And you'll see a lot of these. So these are called wireways, also called wire troughs. Wireways and wire troughs are exactly the same thing. We use these a lot in industry, so it's real easy to pull the wires through these because basically you can lay them in there, or you can use special pullers, and we'll look at that in a minute. We have what we call risers or ladder raceways, and you can see why it's got the name. So instead of being solid, it has individual bars that come across, and you'll see a lot of these used, especially on risers, because what we can do is we can use wire ties and actually tie it onto the actual rungs of the ladder when it goes up there, and that would give us support if we exceed the range of a riser cable. So riser troughs, K-ways, we have T's, horizontal T's, we have vertical splices that we can put together, and we combine these. Sometimes we use a bottom trough, and so you see a lot of these used in industries because it's a lot easier to get to the cable. If I pull this cable through a round conduit, and then something happens, and I don't have access to that cable. I have to literally pull it back out to do something. If we have problems with a cable in a trough, then of course we might be able to repair the cable without actually pulling it out of the raceway and re-pulling the cable. Aerial installation, of course, when we get it up in the air, the big thing is we can put real high ampacity cables through there. They're not put inside a conduit. One of the things we're very concerned with is when we start running multiple conductors inside a conduit, each one of those cables, if we put conductor through that, and every wire has an R, and of course, when I run I through an R, it's I square R, we can do C. And of course, we know that the resistance of the cable, one of the features of the resistance of a metal conductor is that if the heat goes up, its resistance goes up. So what we do when we start pulling these cables through the sealed-in conduit, what we're going to do is we're going to have a maximum number of conductors that we can put into that conduit. So we cannot jam that conductor, even though you see it done something. You see it done sometimes. It's not technically legal. So if we look at the National Electrical Code, and I'll see if I can find that, it gives you the maximum number of area or space you can occupy within a certain conduit. And of course, why we can't say the number of conductors, because I might be running different gauge conductors through my conduit. So what we would have to do is we would calculate the area of each conduit, and it would give what we call a maximum field, which that would be the maximum area you have to maintain within that conduit. So we don't really change the ampacity of the conductor that much. So what the advantage of a large raceway? Of course, we're not inside a conductor. And so these conductors can dissipate heat. So that means we can run higher ampacity wires through a cable tray or cable trough than we can through a sealed in conduit. And of course, low maintenance. So what happens if I've got a wire that breaks inside this conduit? Then what can I do? Well, I have to pull the wire out. You know, if something happens inside there, a lot of times I have a lot of problems trying to get that inside the wire, especially if we got a fire and all these things come in here and kind of melt together. It's extremely hard to get that inside that conduit. And so if we got a cable tray, if we have a problem like that, then what we can do is we can repair the cable instead of trying to pull the cable back out of the conduit so we can repair it. And we'll come in and look at these. I'm not sure right now what these stands for. Non-insulated solid pipe, types of insulation, we'll look at that. And of course, aerial insulation, you got to be able to withstand high wind, which would be storms. And of course, a big thing that we have up north, and every once in a while here in Alabama, we have these ice storms. And so if we're going to do an aerial insulation, the outside, especially outside, if we're going to do this air insulation outside, then we're going to have to make sure we can take care of the wind. This is why when you see these big communication cables, even cables, they'll have a metal wire, and then they constantly strap this up to your communication cable. So this is called a cross member. Y'all seen these. We call these, a lot of people call these telephone poles because most of the time they are maintained, but they are not maintained by the telephone company. They're actually maintained by the power company. So normally these would be considered to be power poles. And then of course, this is when we run our electrical power. Normally we also run our communication cable on these things. And you see these done all the time. So this is a standard power pole with a cross arm. We do see a lot of power poles that don't have the cross arm. They just space it out along the length of the cable. And so what they'll do is they'll put some type of insulator, some type of arm coming out. And then what they'll do is they'll drop down an insulator brace, and then they'll run the cables out here. And you see that done a lot lately. So a lot of your high tension or your high voltage power lines that run out through the community, they usually don't use cross arms. But we still have a lot of power poles that use that. This is a typical down drop for the way a house works, or even a commercial building that uses single phase. Is we run what we call a triplex cable. So a triplex cable, we have two insulated cables. And then, so these would be your two outside lines. And then this right here would be what we refer to as the neutral. But this right here is also earth ground. Now, in house wiring, or anytime we run these cables, we're going to look at two terms that they use. They use hot and they use neutral. And this is people in the field use these terms. NEC does not use this term. They use three terms. They use hot. They call this the current carrying conductor. I'm sorry. They call this the ungrounded current carrying conductor. So you won't see the term hot. And I've run out of room. Plan ahead, right? And then they call the neutral, they call this the grounded current carrying conductor. And and then we have ground. So these are the three things we use. Now, even though the ground and the grounded current carrying conductor are connected together inside the panel box or inside your breaker box, they are ran separate. The grounded current carrying conductor, this guy here is designed to handle current. The ground is in there for safety. So the ground, we use that to prevent devices that have a metal outside from becoming have voltage on them. That should be the best thing to say. So electricians call it hot. This would be your ungrounded current carrying conductor. The neutral would be the grounded current carrying conductor, and then we have ground. When they drop this down from your house, one of these on the outside would be the grounded, one of them would be the ungrounded. In fact, we don't do this. So this is what we have up on the power pole. What we have is we have a center tap transformer. And then what they out, these are your two, so these two outsides, the electricians would call these hots. But both these are current carrying conductors. And they're ungrounded. I'll call them UNG. And then what we have is we have what we call a center tap transformer. And then this is the neutral. So what that means, if you went out, if you got an outside transformer, you'll look at that power pole, and it's going to have a copper wire coming down, and it's going to be connected to ground. And these are the three wires that they run down to your house, and this is called a triplex cable. This guy, since it's referenced to ground, these guys are looking for ground, so they're insulated. This guy's reference to ground. This wire will not be insulated. Your two hot connectors, or your ungrounded current carrying connectors, will be insulated. So what we do when we come over here, we get two voltages off this thing. If we go across all the way across the top, we get what NEC calls 240 volts. If we go between this and the neutral, then what we get is we get what NEC calls 120 volts. So that's where our two powers. So NEC calls our high voltage in our house 240 volts. They call the low voltage 120 volts. Of course, what you get into your house is going to be 120 volts plus or minus, I think, 10%, or 240 volts plus or minus 10% is what you actually get into your house. We drop this down, and then what they do, so what they'll do, your transformer will be up here. And then this would actually hook into your transformer. Your transformer will be referenced to ground. And then your house, when you come over here to your meter is also going to be referenced to ground. Okay, hopefully that makes sense. And this would be a standard insulation on a house. So every transformer, depending on the transformer, is probably going to run multiple houses, unless you're out in a farm somewhere and they run that power all the way out. You pay for them to run that power all the way out. It'll probably only have a very, very small transformer because it's running only one house. Out at my neighborhood, I think our transformer is running 1, 2, 3, 4, 5 houses. It runs off the same transformer. When we pull underground cable, called buried underground cable, we're going to look at this. This picture is very, very poor, and I'm probably sorry about that. But normally what we do, and we'll look and see how they pull this, is the cable is going to be on a big old spool wire. And then somehow they're going to get that off that spool wire into ground, and we'll look at that. Cable pulling. Cables have to be pulled through conduit, floor raceways, cable trays, wire molds, or metal raceways. Before pulling the cable puller, which is you, should check the NEC and manufacturer's cable information chart to determine the suitability of the cable chosen for your job. Check the temperature rating of the cable and also the weight of the cable. Survey the environment and the terrain and come up with a plan on how you're going to pull it and also how you're going to run your conduit. measure the length of the cable to be run to determine the amount of cable required. We don't like to splice inside a pool. We don't like to splice inside a pool. So what we do is we buy enough cable for the pool, is what we do. If we're going underground. Underground, we don't like to splice within the conduit, especially round conduit and underground conduit. You'll never see the power company put a splice down inside the ground. If they got a problem with the cable, they'll pull it back out and run a new cable. Now we do splicing in the air, so you'll see the power company. Every once in a while you will see a splice on a aerial cable, but not an underground cable. What we do is insert the pulling line, existing rope, fish tape, or a vacuum, or we'll talk about a pressure vacuum pull. A lot of people you'll see while they're assembling the conduit, and I like to do this, is I'll go ahead and put my pulling rope through there. So while I'm assembling it, I'll go ahead and put my rope through there. Rigging, we'll look at the type of rigging, tape connection, wire mesh grip, simplex and duplex grippers, and compression type pulling knives. So this is what we call a vacuum puller. And we do have a video on this, guys. I'm going to pause the lecture. I don't know why I don't have a link inside this PowerPoint. I should. Whether this video comes up or not, I'm not sure. But basically, it's just got a bunch of people talking. If the audio doesn't come through, you'll get a feel of what's going on and look at these vacuum or pressure pullers. So let me go ahead and pause this and bring up the video, and then I'll unpause. Okay, this is a video I was telling you about. I did put a link in this. They're referred to it as conductor blowing, which is basically, but what we're going to do is we're going to pull using a vacuum or pressure. And then what I'll do is I'll show y'all some things that some other unique individuals have done as far as using shop vacs to do the same thing, which is pretty neat. A lot better, but this is pretty neat. This guy gets a pretty good detail, and then he doesn't hold on to the that's enough of that video, but you see several mistakes the guy made. First of all, you need to turn your vacuum cleaner on first, and then go back and insert the plastic bag, and you need to manage your string. You need to put it on some type of spool so it'll string off instead of what he used. What I've seen used is people get a regular fishing pole, and they'll just use the very end of the fishing pole and tie the fishing line on there, and then they'll run that through. What you need to do, though, is once you run your first string through, it's a very, very light string. Then what you need to do is you need to attach a bigger string to that and then pull it through. And you might, depending on the size of the pull, you might have to go through about three different ones. So pull a string through, then on the end that you're pulling from, attach a bigger pull string on there, or one slightly bigger, pull that through. And like I said, eventually you might have to do that several times to be able to pull the final pull rope that you're going to end up pulling your thing through. But it's a really neat feature, and most people have a shop vac, and what this does is this makes it really, really fast instead of trying to get that fish tape. And then plus you can get a fish tape usually come in specified lengths, so you could very definitely run out of fish tape real easy and not have one wide enough, but buy you a big old roll of string, and that would be a really neat way to do it. So that would be the self way, and I'm going to show y'all some techniques of people what they've come up with as far as power pullers and stuff like that. But the first one, they was actually pulling fiber optic cable, but you got to understand pulling cable is pulling cable, and the vacuum method is really neat. It's really fast. I don't see how far you saw that going through there, and it's a really popular method of pulling through conduit underground. But we got to be able to attach the cable to what we call the pull hour, to the pull rope. Several methods that we use is, of course, we use tape. Then this would be attaching it to the fish tape. We have what we call mesh wire grips, also called Cleanum grips, which is after the we've got one of these around here, but I'll have to look for it. But these things work on the same basic principle as a Chinese finger trap that we used to have, and I don't know if they still have those anyway. This would be pulling with a grip. So what they've done is this is the actual grip, and this would be when we're trying to pull connectors or cables that's already got connectors on them. Normally we won't do that. Normally we'll pull the wire through and then we'll come back and add the connectors when we get it out. But this would be a pulling grip. So this would be made of, it's got foam rubber inside, then it's got this plastic sleeve, and then it's got a pulling eye up here. And then what you do is once you get in there, you tape it down real good and snug up against the back side. This would be the same thing here. This is basically an inside look. This is a crimp-on pulling eye. So what we would do is we would put our cable in here and we'd actually crimp it onto the jacket. We don't want to pull with the wire. We would like to pull with the outside jacket. This would be a pulling eye. A lot of times though, when the cable comes off a reel, the cable is going to have a natural tendency to start rolling on you. What's going to happen is this is going to pull, especially on fish tape, it's going to try to twist your fish tape into a knot. So what we do is we'll use what we call a swivel. We'll look at sleeves and protectors, and then hand pullers, and then motorized pullers. So this would be a typical swivel. So what happens on the swivel, it allows your cable to be pulled to come up here and swivel when it comes off the spool. But over here on your pulling rope, it's not going to swivel. So this is the pulling swivel. Also, I've seen pulling swivels that look exactly like swivels that you put on the fishing line, especially if you're running any type of spinner type bait, and also you're coming off a reel here. You don't want it to roll your lures or anything. So normally what we do when we pull it in and your fishing line comes off a spool, it's going to have a natural tendency to roll, and then we'll put a swivel out there right next to our lure or what, and it prevents the lure from spinning with the rope. Those pulling swivels look exactly like fish hook swivels. In fact, if it's a real short pull and not a lot of stress, you can literally use just a fishing swivel in between your line and your pull rope and your actual cable that you're pulling. This is what we call a pulling sheave. A pulling sheave we use to not only change the direction of the pull, but it allows us to pull across these loops here. I'm trying to pull my cable, and what we're trying to do is not put a lot of stress on this. So what would happen if I was to come up here and pull it, I would be pulling the cable against the loop, against the edge of this hole right here. So what a pulling sheave does, it allows us to change the direction of the pull, but it also allows us to, instead of pulling it across a edge of a hole or something like that, it allows us to pull it across a pulley, which is pretty neat. So what we could do, and this is what they're talking about, is I could come over here and I could run it like this, and then I would be pulling in this direction. Right here, they're pulling in the same direction, but what a pulling allows us to do is actually change the direction of the pull, so I can pull it in the same direction as we're going. Or I could use it to, and of course we do use this to allow us to pull cables like through manholes and stuff like that. This is a handheld cable pulling machine. So cable pulling, we can either do it by hand, but when we start pulling these big cables, it'll get past what we can do real fast. So what we do is we get these pulling machines. What we do normally on this one is where we're pulling at would be up high. And then what we do is you stand on these two right here, and then you start cranking this thing. And now what you do is you get the mechanical advantage of the length of this pole, the handle, and also if there's any gearboxes in here. Another thing that we use is we use what we refer to as a motorized, it's also called a power puller. A power puller basically has what they call a capstan, and I'll see if I can find a video on this. And what you do is you loop it around once. And then what happens, and if I come on this side on the second loop, So you'd bring your cable in, and I'll draw this as a single wire. So you'd bring a cable in, and then what you do is you'd loop it around, and then you'd come up on the other side, and then this is what you'd bring it back. And what you do is that if you move it out, you get slack, and it allows it to slide on the capstan. If you bring it in and touch this wire, then it'll start pulling. Normally what we have is, we'll look at in a minute, just about all cables have what they call a pulling tension. If you stay below the pulling tension, then they guarantee that the wire won't break, and they guarantee that the conductors won't elongate on you. And we know what happens if the conductor elongates on you. It means that you change the gauge of the wire. So as long as you stay below the pulling tension, and what's nice about these power pullers is usually they'll have a pulling tension gauge on there. If not, then you need to have some other method where you can make sure you keep below the pulling. So what these guys is, you plug them in, you turn them on, you wrap the wire around the capstan, and then you have a control over here where you can actually turn it off, turn it on. You can adjust the speed, which they don't show here very good. So this is the way we'd be using a power puller, a pulling machine, which we just started looking at. This is a real good example of a power puller. So notice the way they have it. So I didn't have enough loops in mine. But what happens is when he lets go, then all this becomes slack, and it allows the power puller to do that. This would be a pulling sheave or a pulling sheave, where it allows us to change the direction of the pull. Also so this, I don't know if you can see it. So these are two pulleys. So what we're doing, instead of trying to pull right here, what we're doing is we're pulling through the pulling sheave, and then it goes around, and up here it goes into the conduit. So by the way, Greenlee is one of the companies that really makes a lot of electrical equipment as far as pulling wire goes. They're pretty much the what we call the Cadillacs of the business. This is preparing the cable for pulling. What we do is we check prints to determine the proper routing. We ensure that the splice and terminating points are correct. So normally if we're going to do if we know we can't get enough cable to do a pull, then what we'll do is along the way is we'll pull the cable into a pulling box. And then what we do inside the box is this is where we'll do our splicing. And also we can use pulling box to decrease the length of the pull. So if I've got an extremely long pull, and then, of course, a lot you do to calculate your pulling tension is what type of insulators you got, and the weight of the cable, and how far you got to pull it. So the farther you got to pull it, the more pulling tension you're going to have. So a lot of times they'll have a splice box or a pull box somewhere out in the center, and they'll pull into the pull box, and then all you have is the pulling distance here. Then they'll come in and they'll feed it back in and pull it into this one, and then you'll just have, and what it does is shorten the distance between your pulls. Check that all necessary materials are available. You start pulling that thing and you run out of wire because you didn't calculate your wire. Check that the pull will occur at a temperature that is suitable. Normally, when you look at the specs on your cable, it'll tell you when you can pull it. It'll give you a temperature. Verify that the proper color codes are being used. It's awful if one end calls for a certain color code to be connected and you pull the wrong cable through. Determine the correct pulling direction. Calculate the cable sidewall pressure for the pull. This is what was talking about. Position the cable reel sheaves properly and watch for sharp bends or kinks in the cable. Determine the proper number of personnel required for feeding the cable. Be sure to apply ample supply of the proper pulling lubricant. A lot of times when we pull through a lot of conduit, we have a pulling lubricant that we put in there. Normally this is a special lubricant that basically does not affect the cable, will not affect the cable over time. You can buy pulling lubricant at Lowe's, and most anybody that sells electrical wire to be pulled. Another thing that you need to do is make sure if you got multiple people, before you start to pull, you need to have a meeting with the people and determine how you're going to communicate with each other. Either you can communicate through walkie-talkies, or if you got two people, maybe through their cell phone, or if you're going to use hand signals. What you need to do right off the bat is verify what hand signals you're going to use with these multiple people in the pool, so you know when to stop, when to start, when to speed it up, and all that other kind of stuff. There it is. Two-way voice or hand signaling communication must be established prior to pulling. Short runs may be pulled by hand. The cable should be fed as straight as possible into the conduit. If basket grips or web grips are used, sufficient distance must be applied to get the positive grip. What I do on these wire mesh grips is I get a real good tension, and also tape it at that tension. Apply pulling lubricant to the cable constantly during the pull. Make certain that the sheaves are the proper size. Leave some slack in the cable as it's being pulled through the box. Be certain to tag and identify the cables if you got multiple cables going through there. Correctly pull tension must be calculated before the start. During the pull, avoid cable crossovers where cables enter the conduit. Reserve special care when pulling cables through manholes where damage may occur, and this is where we would probably use a sheave, right? Do not allow vertical conduit rises to be supported by the conduit fittings. And you have different types of fittings. So what we're talking, if we got rises, especially on EMT, EMT, by the way, is not supposed to be used. We can use it for a vertical rise if it is supported. If it's an unsupported vertical rise, then we have to go to rigid metal conduit. Do not hammer cables into fittings. Such hammering can severely damage the cable. Consider sidewall pressure for vertical hanging cables and being around corners. The direction of the pull and the number of bends affect tension in the sidewall pressure. Be certain that the conduit or feed tray is clear of debris and foreign particles. I think what you saw when they did the pressure when they ran the cable through with that pressure puller, that the first thing they did was actually sent a puck through there to make sure everything was cleared out, any moisture or anything like that was in there. I've seen a lot of people get a nice strong compressor and blow through the conduit just to try to get stuff out. But if you blow through the conduit, make sure there's nobody on the other side that doesn't have safety glasses on or something, because there's no telling what's going to come up out of there. On long pulls, pull from a small box in the center. This reduces the pull tension. Not only in the center, but if you got an extremely long pull and your cable don't have a strong enough pull tension to get through there, then what you can do is you can put multiple what we call pull boxes. So what you would do is you would pull into the box. So we got a real long pull. What we would do is we would come up here, we divide this up into multiple pull boxes. And then what we would do is we would pull the cable or into that box and pull it out. And then we would do what? Then we'd refill it and pull it and do the same thing. And that way what we do is we only have the pull tension for that. Use a protective insert in the entry of the conduit to avoid abrasion as the cable's being pulled. A lot of times the conduit will have a nice cut finish on this, and that means these guys right here could cause damage. So we have these Teflon inserts that we can put inside there, inside the end of the conduit, so the cable will actually be sliding against that, except the rough level, especially the metal conduits where we have problems. When pulling cables into enclosures with energized conductors, use barriers and guards to be certain that inadvertent contact is not made between the people pulling and also any of your pulling equipment. So this is installing cable in a cable tray. So what we have in a cable tray, when we pull it, now if we just come over here and run down the side and lay it in there, and that's still called pulling, by the way, we don't need that. But what we have is we have these roller assemblies that they can install inside the curves in the cable tray. And notice what you have is you have a roller on the side and you have a roller on the bottom. And here's another roller here. And what we do is we can pull that cable around that turn. Use sheaves and cable grips to make the pull. Use cover protection during the construction. Use tension limited tools if the dial-on support grips are applied to the cable. So this is another method we can use. Notice here they have a cable pulley. So what they're doing is actually going around the turn with the pull. Is instead of pulling against this, and we get a lot of sidewall pressure. And a lot of your cable troughs, by the way, turn is not going to be a nice turn like this. It's actually going to be a 90-degree turn. And then what you make sure you need to do is you'd use these pulleys to come over here and then pull it around that. So that's the way we would try to pull it to a trough. Now remember, pulling is the act of laying that, but I mean the act of installing it inside a trough or inside a round conduit. But you know, you might be able to just lay it in there. So lubricants, you can use soap, motor oil, grease, wax, glycerin, water emulsion, bentonite, clay, water, polymer water, hydrocarbon grease. They do make special pulling oils. You have to be careful when you start using soaps and start using motor oil or grease to make sure it's not going to affect the actual outside jacket. So it's better to actually use basically pulling oil or pulling gel that you buy. Pulling tension. Use the following if the pull tension is not provided. So a lot of cables, what they will do is they will actually, when you buy it from the supplier, they'll give you a spec sheet and it will tell you the pull tension. But this is what we would use to do that. Now, what they've done here is they've got us a maximum allowable pull tension, and then what we're going to do is we're going to have pounds per circular mil. So all coppers, then it's going to be all soft drawn coppers are going to be this. Hard drawn aluminum is going to be this. Pounds per circular mil, excuse me. Aluminum power, URD aluminum, we'll have to look up that, and solid aluminum. So what we would do is we'll use this and we'll look and see what we're going to do here. So what we do, this is the basic formula for calculating pull tension if it's not supplied. So tension will be equal to S times N times Kc mil or MCM. So T would be the maximum pull tension in pounds. S would be the conductor stress in pounds per circular mil, which we'd use this table down here, and then times the Kc mil or the MCM. And this should give us our circular mils per, this should give us our pull tension. Pull tension is basically given in pounds. Over here it'd be in pounds. I've seen people monitor this, and you have to go ahead and calculate this before you make the pull. So let's say we had, we'll come back and look at this later. Let me go ahead and get the formula. T is equal to S times N times Kc mil. Exposed cable installation. Protect against penetration by screws or nails by the use of a steel plate or bushing or an appropriate length and width. Use the cable when the cable has passed through wood members. Holes must be drilled or notches made. When cables pass through metal framing members and behind panels, they should be protected by bushings or grommets securely fastened in the opening. Cables routed underground or beneath buildings must be in a raceway that extends beyond the walls of the building. So that means the raceway actually has to come out. You can't cut it flush with the walls of the building, or you're not supposed to. Any cable or conductor that emerges from the ground must be protected by the enclosure or the raceway. Conductors or cables that enter a building must be protected at the point of entrance. Cables must also be protected if they are in the immediate area of any activity where people are walking with tools or equipment. So that means we put them inside a box or something like that. Bending radius. Bending radius is, or what we do on a bending radius is basically we come out from where the bend starts, and we would come from both of them, and then this would set a point out here in space, and then we would go up here, and this right here would give us what we call the bending radius. Now, if you exceed the bending radius, if it's specified, if you extend the bending radius, then you're going to add inductance in the circuit if it's AC, or you're going to add a lot of stress on the cable, and you could cause the conductor to elongate, and we know that's a big problem. These are some of the bending radiuses of the network cable that we have. I don't have the bending radius for Cat 6, but I imagine it's going to be very similar. UTP Cat 5 would be 4 times the diameter of the outside cable. Okay. A minimum of 1 inch. UTP multiple pairs would be times 10 times the diameter of every pair, every conductor you have in there. And fiber is 4 times the diameter of the conductors of a fiber optic conductor. That must be glass. I would have to go and look that up. But these are the maximum recommended bending. You can have a bigger bending radius, but you can't have a smaller bending radius. Pull tension for communication cables. These are in pounds. So 22 gauge copper solid is a maximum of 2 pounds per maximum per conductor. So that means if we got twisted pair, 22 gauge copper or 24 gauge is usually what we use in our Ethernet cables. Then that's 4.2. That's 3.2 pounds per conductor. So 8 conductors. That means our maximum pull-in conductor. And normally we use stranded, and we'll look at that. I mean solid. We'll look at that. So that's going to be 3.2 times 8, and that would give us our maximum pull-in tension on probably Cat 5 or Cat 6 cable. Optical fiber is typically around I'm going to have to come back and look at this. Something don't make sense. Because what it looks like is, I need to look and see at this thing, because what it looks like, this cable looks like it's opposite of what it needs to be. And like I said, I'll go back and look at it and see what's going on. But look, here, so a 22 gauge would be bigger than a 24 gauge, because it looks like it would have, we would have more pulling tension because the wire is bigger. So I'm not really sure what's going on here. So I'll come back and check that and see where I got this. What I decided to do is go ahead and, because this has been going on, this would be, I don't know how long it's been going on, but while I'm doing this research, what I'm going to do is I'm going to go ahead and end this recording, and I'll put a part 2 on this recording. But this is the installation, and then I'll also come in and come up with a couple of problems that we could work to figure out the pull tension. Now remember, this is the pull tension. This is the pull tension that we would use if it's not provided with the cable. If it is provided with the cable, then we would use the pull tension and the pull temperature recommended with that cable. If it's not, this would be the formula that we'd use if that's not available to you. So I'm going to go ahead and end this one. Like I said, I'll figure out that chart that shows the pull tensions, and I'll also come up with some problems that we can work with this, trying to calculate the pull tension. Probably put one of these on the test, but if there's one of these on the test, I will give you the formula and also what each one of these things stand for. And of course, I will make this chart right here available. I have to figure out exactly how I'm going to do that. Well, what I'm going to do is look at the test. There might already be a question like this on there, but right now I can't picture that in my mind, so I'll let you know. Hope you have a great holiday on Veterans Day. And then I'll see, and it was really disappointing me when nobody showed up for my class today. I just don't know. Y'all have a blessed weekend. See y'all on Tuesday, I hope.